Welcome back, everyone. In this lecture, we'll finish off our discussion about NumPy by talking about NumPy operations. Let's open up a Jupyter Notebook and get started. The first thing I'll do in the Jupyter Notebook is just import NumPy as NP, and then we'll create an array called ARR, and this will be NumPy or np.arrange, and we'll say 0, 10, so that we get 0 through 9 there. Let's talk about arithmetic. So you can actually easily perform array with array arithmetic or scalar with array arithmetic, where a scalar number is just a single value number. Let's actually see some examples of this. So if I take my array and I add it to an array, what it ends up doing is it does the addition on an element by element basis based off their index position. So it takes index at 0, adds it to index at 0, takes index at 1, adds it at index at 1, etc. So you can see this basically just doubled every number because it's essentially times 2. So you could also do something like array multiplied by an array, and that does an element by element. So you can see here every number is basically now squared. So 2 times 2 is 4, 3 times 3 is 9, etc. You can do this with subtraction as well. So this should just produce all zeros, and you can even do this with division. Now a quick note on division. If you have a 0 in your array, you'll get a warning. So it says runtime warning, invalid value encountered in true divide. What that actually means is it doesn't really make sense to do 0 divided by 0. It doesn't make sense to divide by 0 or have 0 divided by something. So instead of actually producing a full error, you get this warning here. So keep that in mind. NumPy won't just basically have an error and stop the program. It'll just release a warning for you. And instead what it does, it replaces it with this np.nan value or non-applicable value. Now this will also do something like if you do 1 divided by the array, you'll get a warning as well, but instead it'll replace it by infinity because 1 divided by 0, the closest thing to that is technically infinity. So there's kind of this infinity holder there. But again, it's going to warn you, and usually you don't really want something like this, especially when we're dealing with real values such as stock data or securities data. So keep that in mind. It won't produce a true error. It'll just get some sort of warning here. And lastly, we can actually do exponentials as well. You can do anything with scalars. So if you want to do everything to the power of 3 in your array, you get something like this. And if you want to add the number 100 to everything in your array, you can just do something like that. So basically what this means is this will broadcast this to every single element in the array. And that's going to be really useful later on. Now there are certain mathematical functions that aren't going to be as simple as just an addition or a subtraction. So NumPy actually comes with many universal array functions, and there's a link in your Jupyter Notebook for the documentation for that. And essentially what they are, they're just mathematical operations that you can use to perform the operation across every element in the array. So some really common ones can be something like taking the square root. So you can say np dot, and if you see tab, you'll see a bunch of different methods. Not all of these are universal array functions, but a lot of them are. So you can do something like np.sqrt and take the square root of everything in that array. You can even do things like calculating the exponential. So that can be exp, that is e to the power of everything in the array. You get something like that. You can also do things like figure out what's the maximum value in an array. So there's np.max. And as we saw earlier, we could also just call this as a method off the array. And what's interesting to note is that when you call this method under the hood, what it's actually doing is just calling this universal array function. It's just a different way of calling it. And you can do the same thing with other things. Any basic mathematical function you can think of is available. So if for some reason you want to take the sinusoidal of everything in the array, or the sine of it, there it is, available for you. If you want to take the log of everything in the array, that's available to you as well. Just keep in mind if you have a 0, and that doesn't really make sense to take log of 0, you'll get a warning and it'll say something like negative infinity. Alright, so there's a lot of these that are available to you. As we continue on throughout the course, the most common ones that we end up using are the things that will show up more often. Okay. Thanks everyone, and I'll see you at the next lecture where we'll go over the exercises for the NumPy section of the course.